So hello everyone, my name is Pandy Knight, I'm the Automation Panda. Thank you, Manish, for the introduction. As I said, I'm from Raleigh, North Carolina, and I specialize in testing and automation stuff. I've been around the Python community for a while, very, very thankful to be here. So this is super fun that we're having an in-person conference, and not only that, but a food truck event, so thank you to everybody for organizing. Today I'm going to talk about managing the test data nightmare. One of the toughest challenges in testing any software product is handling the test data. Now, when I say test data, I'm referring to multiple things. Test data includes both the actual data inside the product under test, as well as the data values used by test cases. As testers, we shouldn't underestimate this work of handling test data properly. Good test data is just as important as good tests and good automation. I'm going to say that again. Good test data is just as important as having good tests or good automation. So in this talk, we'll deep dive into the connection between product data and test case data. We'll learn how to pick the right strategies for handling both, including how to avoid data collisions when testing. By the end, you should know how to manage the test data nightmare for your own test projects, whether you're testing something like a Django app, whatever Python project is, or maybe something written in an entirely different language. So, who's ready? Yeah, let's begin. So, let's say we have an application for a bank to provide loans. Sorry, I'm in banking software, y'all. This is where the example comes in. The bank could configure this application for many different types of loans, such as a home mortgage, a car purchase, maybe a vintage Volkswagen Beetle, ooh, or perhaps student loans. All the information the bank needs to provide loans must be stored as data in the system. Each loan product is different. It comes with its own rate, maturity, and payment schedule. The bank must also store information about borrowers, funding curves, and profitability targets for loan opportunities. It's pretty complicated. I do this on a daily. Oh my goodness. But testing requires that all the data already be stored in the system as a prerequisite. So we could write a simple test case to exercise this basic application behavior. I'm going to write it in plain language in a syntax called gherkin. Scenario: create a new loan application. Given the Chrome browser is open and the page at myloanapp.com is displayed, when the user creates a new loan application for home mortgage, and the user enters all their personal information, and the user submits the application, then the page displays a success message with a reference number, and the loan application is sent to the bank. Now, bear in mind, a real loan application will probably need several pages and a lot more data, but for the sake of this talk, let's keep things simple. Simple is better than complex. This test creates and submits a new home mortgage loan application for the user. There are many test data points in this short scenario. Most apparently, there's all the user's personal info. There's also the type of loan, the record of the loan application sent to the bank, and the reference number shown to the user. Furthermore, the URL is config info, and the browser type is a test input. Test data is everywhere in this short scenario. And furthermore, the data is inextricable from the test. Without specific data, this test would be meaningless, right? Unfortunately, the term test data is rather ambiguous. It's a bit of a pet peeve of mine. We've applied it to both the product data in the loan web app as well as to the various pieces of test case data that make even the most basic test work. Product data refers to the real data living in the software system. For the loan web app, product data includes all the bank's configurations and lending information. Test case data, on the other hand, refers to data used to define test cases. It may include values to enter into the product under test, inputs to control how testing is performed, or records to retrieve from the product. In the latter case, test case data is really a reflection of product data. Its values refer to entities existing in the product data. The two types of test data here are separate, but nevertheless connected. Distinguishing these two types of data is important for managing our nightmare. The dependency of test case data on product data can be brittle. For example, consider our test case step to create a new loan application for a home mortgage. This step works as long as the bank's web app is configured for the home mortgage. However, the product data could be changed at any time, just like product code. What if the specifics of a home mortgage change? What if the loan is no longer called a quote-unquote home mortgage, but a quote-unquote personal residential loan? That would make test cases break. Compounding breakages can cause a nightmare for test management. So, how should we manage test data? For feature testing, test data is just as important as test cases and test code, like I said before. How do we handle both product data and test case data? Are there strategies we can use to avoid these brittle dependencies? In this talk, we'll explore multiple ways to handle both product data and test case data. Unfortunately, there are no universal or perfect solutions to the test data problem, but you can avoid nightmares by picking the strategies that work for your needs. Let's start with product data. As stated previously, product data is any live data in the product or system under test. In simplest terms, it is everything in the database. Examples include user accounts, administration settings, product customizations, records created by users, files uploaded by users. For our example loan app, product data would be most of these things: the user accounts, the loan product settings, the loan application submitted by the user, and all that behind the scenes bank data. Data must be present in the product as a prerequisite for most testing. There are two primary ways to get that data in the system. On one hand, you can set up the data before running tests. This would be static data preparation. For example, the loan web app could be set up with a set of pre-registered users and a collection of loan types. Test cases, whether they are manual or automated, can presume that the static data is already in the system and simply reference it. Static data preparation is a good strategy for complicated data or data that is slow to create dynamically. For example, user accounts may need email verification. So it might be easier for automated tests to simply use a set of pre-registered users. Tests will learn faster if they can simply reference existing data instead of creating new data each time. However, static data must be maintained. Any changes to static data could impact tests too. Static data may also become stale over time as data formats are updated or if data is time sensitive. On the other hand, you can set up data during test execution. This would be dynamic data creation. In the example loan test case, the loan application document is dynamically created. The test does not reference an existing loan application, it creates a new one. Dynamically created records avoid the brittleness of hard references to static data. They can also be used exclusively by the current test case, protecting them from interruptions by others. The main downside of dynamic data prep is the execution time. It will slow down your tests. Dynamically created data is essentially disposable too, so you will need some sort of cleanup or decay strategy to handle it. Which strategy is best? Typically, testing requires both strategies together. It's not either or. Data that is slow to set up or considered immutable should use static preparation, while data that is quick and easy to set up should use dynamic preparation. When I develop test solutions, I prefer to create as much data as possible dynamically per test case to preserve test case independence. When a test creates the data it needs dynamically, it will be the only test using that data and therefore has a much lower risk of collisions. These two data prep strategies are a bit complicated when implementing them. Dynamic prep really depends upon the test case, so instead I'm going to focus on strategies for the static data prep. One moment. The simplest data prep strategy is manual configuration. That's exactly what it sounds like. Testers log into the system and manually create whatever records they need to be in the system. That could include creating users, configuring settings, and saving records. The nice thing about manual configuration is that it's low tech. Anyone can do it. You don't necessarily need to be an engineer. It doesn't need fancy or complicated tools. However, manual configuration is slow, and it does not scale well for large systems or large test environments. Furthermore, manually configured systems can easily fall into disrepair without any automated mechanisms for maintenance. A better strategy might be automated configuration. Woohoo! Automation Panda, right? Yay! Rather than manually set everything up, automated tools can create the desired data. This could be accomplished in many ways. Reusing UI interactions from tests, calling REST APIs, or even possibly using tools like Puppet or Chef. Automation could generate data deterministically or randomly. The main benefit of automation is the ability to create fresh data at any time. Automation can also clean data, like scrubbing private fields or updating time-sensitive fields. Handle that whole GDPR thing. Unfortunately, automated configuration is not a free lunch. It requires extra skills, and code must be maintained. If you want a shortcut, you could try to clone the databases. Cloning databases is easier than ever with cloud management tools. You could maintain one database in a golden state, and then create a copy before running tests. Once testing is complete, the copy could be deleted. Granular cleanup would not be necessary. Database clones make it easy to copy all data at once without worrying about any damage that rogue testing could cause. However, databases can have a lot of data. We're talking bajigabytes. So cloning large ones may not be practical. Clones may also need extra refinement to scrub special fields to hook them up properly. Finally, if managing real data is too much of a hassle, then you could mock endpoints. This would completely remove dependencies on databases and even services. All data returned by the mocks would be deterministic too, yielding consistent results. However, mocks are not always the right solution. They often require a lot of extra effort to set up, and mock data can make tests overlook unpredicted real-world variations. Mocks also mean that tests will not truly be end-to-end in coverage, if that's something that matters for you. These strategies can also work together. For example, you could use automated scripts to configure product data in a golden database, and then you could make clones of that database for testing. In another example, in a large testing environment, you could choose to mock some endpoints while using real data for others. There are multiple factors that should be considered when deciding the best strategy for static data prep. How big is the data? If it's small, manual config may be sufficient. However, if it's large, then automation may be required. How fresh does the data need to be? Or how frequently will the data need to be updated? In these cases, automation can help with these problems. How difficult will it be to try advanced tricks like mocking or cloning databases? This may be especially difficult for old legacy systems. Is there any bureaucracy in the way of automated solutions? Hey, it happens. We live in the real world. Not every organization embraces testing and automation. Bureaucracy can stonewall advanced solutions that need extra support. Do folks have the skills required for automation, database administration, or mocks? Skills may be a barrier at first, but training and learning can help the team overcome any limitations here. And finally, what about the cost? None of these is a free lunch. Each data prep strategy has some sort of cost. Teams should do a cost-benefit analysis when deciding which strategy they should use. So, that's product data. We're halfway there. Let's now take a look at test case data. Test case data is inherently part of test cases. Let's revisit that example we had from before. As we saw before, there are multiple bits of test data throughout the steps of this short scenario. They represent different types of test case data. First, let's look at the first step. Given the Chrome browser is open. The Chrome browser is test case data because it specifies the type of web browser in which to load the web app. This is what we call a test control input. It directs how tests will be run rather than specifying feature behavior. It's an important distinction. Theoretically, the test could run the same on any browser type, but the steps simply dictate here that we're using Chrome. As a best practice, test control inputs should not be hard-coded into any test automation code. Instead, they should be passed into automation as inputs. That way, tests can easily be retargeted. And there's a few ways to do this. The simplest way would be to create a flat file with input values. I recommend using a format like JSON or YAML because they are easy to write, easy to read, and easy for programming languages to parse. In fact, in Python, to parse a JSON file is really only about 1 or 2 lines using the JSON module. The other nice thing is that these kinds of files can have line-by-line diffs. Test automation code can read the file before any tests start, and it can inject input values as appropriate. For example, if you're using something like PyTest, you can write a fixture to read your JSON or YAML input file, and then inject those using the fixture mechanism that PyTest has. Using this JSON file, the automation could read this browser type and construct the Selenium WebDriver object for Chrome for each test. The path for the input file would need to be hard-coded into the automation, kind of hand-wavy there, but it could be as simple as a standard file name like inputs.json in the current directory. Another way to handle inputs is using environment variables. Testers could set variables from a system shell or a profile, and automation code could read these variables by name. This can be useful for integrations with continuous integration servers or Docker containers. However, it can be a little more dangerous because anyone could change variables at any time. Nevertheless, automation can read these variables before tests start in something like a PyTest fixture and handle them appropriately. So let's remove that hard-coded step for browser type from the scenario. That should be handled as an automation level concern. Next, let's look at the second type of test case data. Notice how the URL here is hard-coded. This is also not a good practice. Typically, development teams host multiple instances of products under development, like a development environment and a staging environment, maybe even a test environment. So hard-coded configuration information like this limits where tests can run. Any information about a product's configuration is called configuration metadata. This can include things like URLs, usernames, passwords, and possibly other descriptors. There are a few ways to handle config metadata. You can use flat files or environment variables like we did for test control inputs. But I recommend using flat files. Now, I also recommend separating test control inputs from configuration metadata. Create an input to refer to the target configuration and store multiple configurations in the config metadata files. That way, testers can change just a few simple inputs to target a new configuration, and they won't need to change multiple configuration fields regularly. If you want to be fancy, you could create a web service to provide config metadata, or you can use an existing one like Azure Key Vault. These will be especially helpful for keeping secrets like passwords safe. But creating such an endpoint may be overkill for your needs. Either way, the test step can be rewritten to refer more generically to the web application. Automation can select the target environment using the inputs and the config metadata. The remaining pieces of test case data all fall into a category called test case values. These values pertain directly to the behavior exercised by the test, not to any configuration factor. Even in this classification, there are subtypes. Whew. The first kind of test case value is a literal value. These are the values that are hard-coded in the test. In this test here, the table of personal info contains literal values. Literals are simple to use, and they provide specification by example. Literals should also be independent of any statically created product data. They should be values that can be safely originated by the test case. The literals in this info table will be entered as input values into the web app. And theoretically, they could be any values. We could change the name, and we could change the address, and we could change all those numbers. The second kind of value is what we call an output reference. These are values that are retrieved from the product under test. Typically, they are the outputs generated by exercising a behavior. In this example test, the reference number can be scraped from the success page and verified for correct format. The loan application can be retrieved from the web app's backend to verify it was correctly submitted. These values cannot be literals because they originate from the product. Say that again. These values cannot be literals because they originate from the product. Tests must refer to them by a reference and retrieve their values. As a side note, this whole section here is where the test dynamically created that loan application. So this is an example of dynamic data creation from what we covered earlier. The third and final kind of test case value is the trickiest. It is called the input reference. At first, these may look like literals. However, input references are values that directly refer to product data. While personal info like name and address are created dynamically by the test case, the name of the loan type refers to the loan configuration already in the web app. Thus, this test has an input dependency. It must specify the type of loan, and the loan type must already exist in the product. The simplest way to test this, or the simplest way to write this test is simply to hard code that reference. That's what's being done here. The name home mortgage refers to the name of the loan in the web app. Automation can use that name when selecting the loan type from a button or dropdown. Hard-coded references make it easy to write tests, but they require statically prepped data to exist in the system. References also become hard to maintain when the product data changes, or when the same test must run against different configurations with different names. For example, we talked about earlier how a home mortgage may be called a personal residential loan in some other system or configuration. One way to avoid the pain of static data is to dynamically create these records or configurations. If the test calls the backend to create a new loan product named home mortgage for each test run, then static pre-prep isn't needed. However, we already know the pain points of dynamic prep. In this case, let's say dynamically creating a new loan type is just too slow. A more robust solution could be data discovery. Let's say the target web app is already configured with multiple acceptable loan types. Instead of hard-coding the name of the desired loan type, the test could describe the loan type and then use automation to search the web app's config to find a loan type matching the desired criteria. For example, if different regions of a bank have different names for this type of loan, the discovery mechanism could look into the configuration for a satisfactory home mortgage loan type and return the specific name for the current bank region. Discovery enables tests to search existing data for required records instead of hard coding records. Discovery makes tests more resilient to changes in product data. It's great when testing multiple configurations with ever so slightly different values. But it does require extra coding, and it may be overkill for smaller projects. Whew! That's a lot of info. So, in summary, test control inputs direct how tests will be run, not what behavior is covered. They should be supplied via flat files or environment variables. Configuration metadata describe product configuration for the target environment. They should be supplied via config files or service API calls. And test case values direct the behavior covered by the test. They may be literal values, output references, or input references. And input references may be hard-coded or discovered. Is everyone still with me? I know I just dropped a heckin' ton of info on you. We good? Woo! Cool. Breathe. It's okay. So you're probably thinking at this point, wow, that's a ton of information. Thank you, Andy. We're done. We're ready for Q&A, right? Well, hold on there, partner. Nightmare's not over yet. Bum, bum, bum. There's one more thing to address. Collisions. That's right. Collisions can happen whenever multiple actors operate on shared resources. For example, they could happen whenever multiple testers simultaneously access the system or when automated tests run in parallel. And collisions are a heckin' pain. We got to take additional considerations when looking at collisions. First and foremost, Isolate your test environments. Please isolate your test environments. Prevent external actors from interrupting tests. If you have a shared test environment, unfortunately, like I do at my job, block other users from accessing the system when tests are running. No interruptions, please. You might need to schedule tests to run during off hours, hence nightly tests are pretty common. You might also want to set up multiple test environments. If the product under test is containerized, or if databases are easily clonable, then you could dynamically create fresh environments for each test launch. That would be living the dream. And that would guarantee perfect isolation. Second consideration, treat any shared data as immutable. And when I say immutable, meaning not changing or constant. Sometimes shared product data is unavoidable. For example, if tests run in parallel against one test environment, they may use the same product data. Or if an application has multiple components because it's just so dang huge, certain components may be difficult to isolate for testing. Whenever data must be shared, treat that data as immutable or constant. Don't let anything change it. Any changes to shared data could break tests. For example, one test might require a car loan, but another might delete the car loan type from the database at the same time. Any tests that must alter data should be run serially instead of in parallel, and they should always undo any changes they make. Third consideration, and finally, use dynamic preparation as much as possible. Like I said, I try to use it as much as possible when I can. Tests cannot collide on data that they don't share. Right? Keep statically prepared product data to a minimum. Sometimes you can't avoid it, but just try to minimize that scope. Because statically created data is more likely to become shared data, and shared data more likely to cause collisions. Boom! We did it. We covered a ton of material. So let's recap real quick what we've learned about test data in this half hour. Two kinds of test data: product data and test case data. Product data can be prepared statically or dynamically. Test case data either control how tests run or reflect product data. You gotta handle references and shared data carefully. And finally, if there's one major takeaway I want you to have, it's this: choose the best strategies to defeat your nightmares. Every product is different. Every team is different. Take the strategies I shared with you today as suggestions for things that you could try. So, thank you so much for listening to my talk today. Again, my name is Andrew Knight, Pandy for short, and I'm the Automation Panda. Be sure to check out my blog, automationpanda.com, and to follow me on Twitter @AutomationPanda.